Hi, I'm Max Guernsey with Protocor. In this video, we're going to look at transforming your code so that instead of a bunch of direct calls to constructors, we use a builder object. Now, if you look at the code in front of you, it's not impossible to understand what it does, especially at a high level. It creates a bunch of rectangle objects. We all know what a rectangle is. And it uses them to paint onto an image. We all know what an image is. It saves it and it launches it. So let's take a look at the output. I'll go ahead and run it. Just take a second here, and there is the output. Bunch of rectangles, all kind of painted one on top of the next. Got one that's tilted with an empty fill and all of that. What's hard is to really look at one of these lines here, like line 7, and parse it in your head and say, this is the rectangle that is being built. You can see that it's got coordinates at 0, 0, and you can maybe guess that means the top left of the image. And you can see that it's got coordinates of 1, 1. And if you look way over to the right, you can check that it's measured relative to the picture size. And so maybe that's the bottom right. And then there's this color wheat, and since we've run it, we can guess maybe that's the fill, and so on. But it's not readable. It requires a lot of work to interpret this, and that's not what we want. There's a lot of reasons for the builder pattern, but the first one that I think we want to address is just being able to understand what object is being requested at any given point in time. So let's get started. The first thing I'm going to do is I am going to encapsulate a constructor. So I'll use ReSharper to do that. I don't actually care what the name of this method is because, as I so often do, I'm going to end up inlining it. It's really just a temporary thing to help me in my refactoring efforts. And then I'm going to take this expression and I'm going to extract another method, and we'll call it build. I do care what the name of this method is, for reasons that will become apparent shortly. Now this method is ultimately going to be the method that lives on the builder, but we don't have a builder class yet. If you've watched any of my videos before, you probably know what I'm going to do. I'm going to use transform parameters to produce that builder class. Now I have a class called builder. ReSharper puts it at the top of the file. I want it to be an inner class, so I'll just drag it where I want it to be. And now it puts it at the bottom, I think. Yeah, puts it here. Okay, and if we go to the constructor again, you can see we have this builder object that we pass in to build. So I will extract that as a variable. Now I have a build method. Now this build method is kind of wacky. It's got all these variables in it we don't really need. So I'm just going to quickly inline those. By the way, this is an involved refactoring operation because there's so many repetitions of the same operation. So there may be times that I fast forward. Like if I've shown you the operation I've done once or twice, then I may go, oh, well, I'm going to do this 7 more times. I don't think you need to watch me do it in detail. And so I'll speed it up by a factor of, 4 or 5 or 10 or whatever ends up looking right. Okay, so we've cleaned this method up. And now we can make it non-static, which will move it to the builder class. Now we have a builder class with a build method. Okay, the next thing we want to do is get rid of this constructor. Because so far all we've done is replace one constructor that's way too long with another constructor that's way too long. But that's okay, that's how refactoring works. You do it in little incremental steps. Sometimes you even make things a little worse in order to reposition the code to make it better. We'll see a great example of that later. So the first step I'm going to do in this arc of the process is I'm going to change it from an implicit constructor to an explicit constructor. Doing that allows me to extract a method. It doesn't really matter what I call it. Just call it new method. So that I can capture all of that constructor logic. That method I can then make into a static method, and be sure to add this parameter. Now when I look where I construct this, well, I only construct it in one place. This means that I can then go and call that builder dot, no, I always forget to do this. Remember to make it public. Okay. I can call that method on the builder I've created and basically just pass in the exact same parameters as before. So now I create a builder object. It calls this new method with all the construction logic, and then I immediately call the new method again. Well, I don't need to do it twice, so I can get rid of the one in the constructor. This allows me to delete all of these parameters from the constructor and rely purely on assignment. Okay. Now, I know that the next step, that ReSharper is a little wonky about how it does naming the next step, so I'm going to change all of my parameters and all of my properties names, that is, in order to support ReSharper's flakiness about names, or its assumptions about naming conventions. This is not something I would tolerate normally, but it's temporary. It's just there to make ReSharper happy. So if we look, now we're only calling this new method in one place. This is all of the initialization logic for the builder, which means I can inline it. So now what I've done is I've taken all of that initialization logic from the constructor, and I have scooped it up safely and put it inside this method, this create instance method, completely transformatively, in a way that I am completely confident that I have not changed anything. Now I'm going to do something that does change something, just because I can't stand the fact that ReSharper doesn't update the coloring. Just cut and paste so that the coloring is updated correctly. Now what I wish I had was builder methods. Methods to initialize the builder. I don't want to just assign all of these things. I want methods that allow me to initialize in a meaningful way. So the first step to that is just to group these various steps in kind of logical buckets. So the top and the left, that's the anchor. The width and the height, that's the dimensions or the size. The fill, that stands on its own, but the border and the border thickness, those guys are kind of one thing. That's like a description of the border. The frame measurement mode we're going to leave completely separate. And let's see, the corner rounding amount. Well, the corner stuff actually lives together. And then the rotation degrees, they kind of live on their own. Now, what I want to do is I ultimately want some methods, but first I'm going to do a little bit of preparatory logic. Okay, so I think I want to do this. If true. That's a safe thing to do, right? And actually, let me just do it for every single line. That's not going to change the behavior at all. Just pass that through. There, 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 and there. Now, what I want really is not for this to be true. What I really want is for this to be something that only is true when this initialization matters. So if I have a left value and it's equal to underbar left, then I don't want to do this assignment. Now the reason for that isn't because I'm trying to optimize execution time. This is actually necessary for a later step in introducing a builder. I need these branches to be in place so that when I inline this create instance method, I'll have branches that I can use to delete code that doesn't need to be at any particular call site. That's one of the problems is we have all of these variables, these constructor parameters that we have to pass in, but we're not really using in certain circumstances. So I want to be able to only make the calls that matter. So what I'm going to do is I'm going to replace this with a simple statement. If builder.left is not equal to the left value, then assign it. That feels extremely safe to do, because if it was equal, then the assignment doesn't do anything. So we'll just go ahead and paste all of these expressions in, and turn them into not equals. Okay, this is pretty good. Now here's the thing, we're always assigning these values if we're not assigning the default value, which means when we're actually initializing the builder object on this line, which is the only place we call the constructor, we can do whatever we want. That means we can assign default values. Like for instance, I think a good default fill is transparent. A good default border color is black. A good default border thickness is 5 pixels. A good measurement mode is absolute, meaning by pixels. And a good corner rounding mode is none, no corner rounding of any kind. Okay. It doesn't matter what I do, because if the same value as this is passed in, then it won't get assigned, it won't get changed. If a different value is passed in, it'll get assigned. So setting these to whatever I want, whatever's convenient, whatever I think supports the design of this builder pattern best, it's my option. All right. Okay. So now I can actually do something interesting with this. So I can transform these conditions to be whatever I want. For instance, I could say some value. Well, what do I know left is? I know left starts out as 0. Same with top. Actually, that's true of width and height. What's the fill? It's transparent. So I'll just copy its default value. In fact, since I'm using default, if I really wanted to be transformative, I'd say default, right? But then it doesn't like that, and then I could replace it with 0. So I know 0 is safe. Okay, so we go to the border color. Well, what's the border color? The default border color is now black. So I can say only update this when the border that's being passed in is not black. Border thickness, I say default. It complains, then I change that to 0. Okay, frame measurement mode. Oh, see, we've got absolute. And we can just replace that. Same with this amount. Corner rounding amount defaults to default, which I can then replace with 0. This corner rounding mode is none, but I'll just go copy it and paste it to make sure I'm transformative. And the rotation degrees is default. So we'll say default 0. Okay, that's pretty good. Let's do some more things. Well, so I can do this. Now I'm going to do something that you might find weird. You might say, well, that's not transformative, but I'll explain why it is. I'm going to take this line, I'm going to copy it, and I'm going to paste it. And the reason why it's transformative is at the end of line 100, builder.corner rounding amount is always equal to corner rounding amount. So assigning it here is irrelevant. And then what I'm going to do is I'm going to say I want to do this, or I want to, or some other reason, something else that's true. Well, the other condition, sorry, not or true, or something. The other condition that I want here is this one. So now I'll assign the builder corner rounding amount and the rounding amount if either the rounding mode is different or the rounding amount is different. No matter what, by line 106, these values have been assigned or left alone correctly, which means I no longer need that. And I can do the same thing for the other logical blocks. I could say, okay, well, we'll copy this line here, and we'll add this as one of the reasons to go in. And we're producing the exact same effect, no matter what. And we'll create another block, copy this line, add this condition as another reason to go into that path, and delete the other path. This one we don't need to. Okay, so the border is another example. Copy, and we'll copy this line, paste it down here. Now we don't need that. So now what we've done is we've transformed this into logical steps. If we have anything about the anchor that is not the default anchor of 0, 0, then we're going to set the anchor. If we have anything about the dimensions that is not the default dimensions of 0, 0, then we're going to set the dimensions. If the fill color is not what we expect, is not transparent, we'll set that. If the border thickness is not what we expect, or the border color is not what we expect, then we'll set the border, and so on. This puts us in a position to start extracting methods. So I'm going to do that. We'll call this set anchor. And we'll take that method and we'll make it non-static. So now builder.setAnchor left and top sets the anchor to left and top. We can just repeat this process. Okay. Now what do we do? Well, we'll go and we'll change these a little bit. So refactoring is okay when you are guaranteed that you're not changing the behavior of the system. Here we have a method that's void. So it is literally impossible for anything to be coupled to what it's returning because it's not returning anything. That means I can set what it's returning to anything I want. And because I want a fluent interface, fluent API, I'm going to have it return this. And I'm going to do that to all these methods. They don't change the behavior at all. Pass it in, paste it in, and one more. So that was an easy thing to do. Now we'll go back, and what other changes do we need? Oh, the naming. Yeah, so we go here and we look and they say, well, these names are weird. They're weird to me because I don't use the underbars or anything like that. So now that we've done the refactoring we need, I'm going to go back and change these names to be what I want. Okay, and the other thing I realize as I look at this is all of these properties, they're only used inside this class. So I can make them private. And I also have no good reason for them to be properties. So I'll simply make them into fields. A lot of times I'll create a regex to do that, but that's out of scope for this video. Okay, so I've encapsulated all the data in the builder. Now you have to use these set methods in order to, these semantic set methods, set the anchor, set the dimensions, whatever, in order to configure it, and then you have to use build in order to get a new instance of a rectangle. So I think we're just about ready to go to the last phase. We've cleaned all this up, and the last phase is, remember I told you, this create instance method, I didn't care what it was named because I was going to inline it. Now is the time. I'm going to get rid of it. So now, everywhere where we were calling, we had one line of code. Everywhere where we had one line of code, we have a bunch of lines. And you might be going, no, this is so much worse. Well, like I said, sometimes you got to make it worse in order to make it better. The reason we created all of these conditionals was so that we could exploit resharpers or Roslinators, or if you're working with Java, IDEA or Eclipse's built-in logic around evaluating when branches are dead. So see here, it's grayed out. It says you don't need this, so we'll just get rid of that branch. And I can do the same thing here. It can tell that it's always going to happen, so we can just invert it and get rid of it. Invert says transparent is equal to wheat. Well, it's never equal to wheat. Transparent and wheat are different. Okay, so we'll get rid of that one. That one doesn't help. And then we'll invert this. This is black is equal to transparent. That's never true. So we can just delete. Invert, get rid of. Here we've got a dead line of code. Here we've got another dead line of code. Okay, and now we've just got a bunch of calls to our builder. Remember, I did that work so that we can make it fluent, so I'll just replace this statement with a continuation. And that's safe because the builder is equal to the builder object. That's fine to do. And then the same thing is true here. Set dimensions, we know, returns the same object that it was called on, so we can just get rid of all of these safely. And what we're left with is a very, in my mind at least, a very clean description of what the background looks like. It's the size of the picture. We have the relative to picture size, and the dimensions are 1, 1. That's a lot easier to understand for me. In fact, it'd be even easier to understand if I just move it there, right? It's relative to the picture size. Its dimensions are 1, 1. Its fill color is wheat. It has no border. So we just create that. Now I'll do at least one more, and then we'll go into fast forward mode because it is a little bit meticulous, tedious to do this. So again, we're going to invert. We're going to get rid of the empty branches that inversion creates. We're going to invert here, and we say, oh, well, transparent, is that green? No, it's not. Invert, and it can tell we don't need that, so we just are always going to run that code. This never gets run, so we just get rid of it. Slowly we collapse this code down until it's clear that we don't need it, and then, or clear there's nothing else we need to get rid of, and then we start converting over to our fluent call, fluent API call, and we end up with a nice, clean description of what that first light green rectangle looks like. Okay, the process is the same. We just go through all of the call sites and we collapse all of those ifs down into our fluent call. I'm going to go through them, but I'm not going to narrate it or anything. If I can find some good stock kazoo music to go with it, maybe I will, but I'm probably not going to pay anything because I'm cheap. So here we go. Okay, so I have gone through the same process for all of them, and I have produced a pretty straightforward explanation of what each of these rectangles is. You can clearly see the 50-50, those are the anchor, that's the anchor point. The dimensions are 900 by 900 here. 100 is the anchor point. The dimensions are 300 by 200. And, yeah, these are positional, but who doesn't know that X comes first and Y comes second, right? We could say top left instead of anchor, and that's easy to do, right? We could just say, change name, right? Set top left. Set height width. Except it would be width height. Set width watt height. And it's very easy to do changes like that because we've got a design that actually fits the shape of the problem we're trying to solve. So now it's easy to see what kind of object we're creating. We also get all of the other benefits of having a builder pattern. We've encapsulated not only how we construct an object, but what object is being constructed. Maybe we want to start building shapes. Maybe we want a shape builder interface. We've got circles and lines and all that other stuff. Who knows? We're set up to fit into that now, and we weren't as set up for that before. We also have the ability to create like stamps, right? You want to have green with a black border that's 5 pixels wide. You can create an algorithm that says, here's my style. The fill and the border are this, right? You have all kinds of advantages that come from having created this abstraction, not least among which is that it's very easy to read each of these construction lines. So I guess the moment of truth has come. I'm going to hit Control F5 and see if it produces the same image. And there it is. All right, well, that's it for refactoring to the builder pattern. I'm Max Guernsey with Protocore. Be sure to check out our YouTube channel and other videos. If you found this one helpful, maybe the other ones will be helpful too. Thank you.